Hello, everybody. I hope everybody's having a good week. I decided that I was going to try and do some examples and kind of align them with the assessment for week 3 because some people are really struggling with the assessment pieces. If this seems to work, I'll go back and do another one for week 1 and week 2. But again, I hope everybody's doing well. This is Miss De La Garza, by the way. I'm going to try my best to do a whiteboard kind of example. And then, so if I mess up, this is my first time doing it, just kind of bear with me as I go through the tools I'm trying to use. I'm going to try to use this whiteboard. All right. So if you're looking at the assessment for week 3, we're talking about exponential functions. For question 1, it talks about what shows growth and decay, or which shows growth and decay. Remember when we do exponential functions that y equals a times b to the x is the equation that's used for exponential functions. So we need to know what is a and what is b. A is always going to be our beginning value or initial value. Try to use this. And then B is what shows growth or decay. So if you look at B, if it's more than, or if, I should say if it's, let me do this. Still trying to get used to this. If it is 1 or more, then that's a growth. If the value in the parentheses, because it's in parentheses, is between 0 and 1, then that's a decay. So I'm going to go ahead and kind of show you some examples of what that might look like. So hopefully I'll got some of this down. It is helpful to take notes when you're doing this, when you're with your teachers doing your Zoom presentations, because like right about now, I'm going to take my eraser and I'm going to start erasing things. So Coach Hendrick has a funny story that he always tells about one of his professors in college that used to erase with one hand and write with the other. So you had to take notes really fast. Fortunately, this is a recording, so you can go back and see it. So let me go back. So let's see some, how can we know? Let's see some examples. So if I did something like this, y equals 12, and then I say 1 minus 0.75 to the x. This is another way we can write an exponential expression. This is more of the formula you're going to use if you want to find out how much a car depreciates or how much a painting might increase in value. This is just one of the ways that you can see exponential forms. Well, remember that this is A. So if we're worried about whether it's growth or decay, we're really not worried about that too much. So we don't really need to worry about this piece. We're looking more at the 1 minus whatever's in parentheses, the 1 minus. So automatically, I know it's not a growth because it's a minus. It's 1 minus. That can't be a growth. That's automatically a decay. So this one would be a decay. Also, if you did 1 minus 0.75, if you just put that in your calculator, that would end up being just 25 cents. And remember earlier I said any value that's between 0, and 1 is also a decay. So either way you need to do that to figure that out, whether you can just look at it and know that it's a decay, or if you want to do 1 minus 0.75 and know that that's 0.25, that works, okay? So we know that this example, this is a decay. So let's do another example. So let's say I have y equals 1/2 times 1.1 to the x. Again, we're not going to worry about the 1/2. That doesn't matter. What matters is this right here. This is our b. This is what shows us either growth or decay. Remember, it's a growth if the value is 1 or more. It's a decay if the value is between 0 and 1. So for this, I kind of like to think about money. If I do 1.1 and then I put a 0 behind it, that looks like $1.10. So that would be a growth. It's more than 1. A lot of people get confused when they see decimals because they think decimals automatically is a low number. No, not necessarily. What you can do is whatever you have in parentheses, just put a 0 behind it. Think of it as money. $1.10 is 1 or more, right? This is more than $1. So this is a growth. So this expression that you're looking at, y equals 1/2 times 1.1 to the x value, is a growth. All right, let's look at another one. If I had something like y equals 15, 0.6 to the x, again, we don't care about anything but what's in the parentheses. That is your b value. That's what shows growth and decay. Again, I can think of this like money. So I'm going to do 0.6, and this is not 6 cents. This is 60 cents. Okay? So 60 cents is between 0 and 1. It's between having no dollars and $1. You have 60 cents. So this would be a decay. All right. Let me go over one other thing for this piece. We had on the assessment that you're doing on the first question, it gives you those equations and it asks what, I can't remember if it's asked whether it's a growth or decay, but we just went over that. But there is one answer choice that's not even an exponential function. You'll need to remember how you write all these different functions. So the one we were working with was exponential. And that is shown as y equals a times b to the x. This is the exponential formula. And it's written with a number and then a number in parentheses to the x power. It can also be written like this. We'll go over that here later. Or a if y'all remember in class, these were T's sometimes, and they represented time. Just remember that these letters, like X and T, they just represent numbers that we don't know. That's why we use letter. We don't know this. We don't know what A is. We don't know what B is. We don't know what X is. They all just represent numbers that we don't know. So these are the ways that you can write an exponential function. Remember that a linear function or a linear equation is written like this. We did this a lot. Y equals mx plus b, where m is the slope and b is the y-intercept. And then we have quadratic, where it was y equals ax squared plus bx plus c. So on that assessment that you're looking at for week 3, for question number 1, it's asking which shows growth or decay. Well, if it's written like a linear or a quadratic, it's not even exponential. It can't even be one of the answer choices. So you can just get rid of them if they're written like these, because we're not talking about linear or quadratics. We're talking about exponentials. And hint, it's going to look like this. All right. All right, let's go move on a little bit. Everybody seems to be doing okay with the pictures, the graphing pictures, whether it looks like a growth or a decay. Remember that you read your graphs left to right, just like you would read a book. So we have, can look like this or like this. Then you have your okay. So this, we read left to right at the top, that shows a growth. It's going up from left to right. So this is a growth. If you read the lower one from left to right, this would be a decay because it's going down from left to right. If you need to draw a picture of a man, you can do that too. We start on the left. If he goes to the right, he's going up. Same thing here. If you draw a man here, you start on the left, you move to the right, he's going down. Remember that if you have a perfectly straight line, that's a linear. That's not even exponential. So right now, we're not talking about linear, so that can't be an answer choice. So just remember those things. The last thing I want to go over, got my notes over here. See, I even have my own notes because I got to remember what to talk about. Remember that when we're going, the exponential exponential equation is y equals a times b to the x. A is your initial value. All that means is your beginning value. Where did the amount start? Then B shows growth or decay. All right, so the last problem you have on one of your questions has a word problem. I'll kind of give a little bit of an example. It's not the question, but it's a lot like the question. You have a new painting, and you bought it at $500. So whenever you're reading a word problem, just highlight the important stuff. So you bought it for $500. This would be A. That's your beginning value. That's what you bought it for. Then the value of the painting is going to increase. It might use the word increase, go up, a growth, any kind of vocabulary that uses that means it's a growth. It's going to increase. So that's a growth. And then it's going to increase by 5% each year. That's a lot. I mean, I'm going overboard, but I'm just trying to give you all a little example, 5% each year. Remember that you've got to convert percents into decimals to do this. So we start at the back, we move forward twice. So that turns into 0.05. All right. Now, when we write this, we're actually going to use the other equation, and I'm going to erase this up here. We're going to use the other kind I was talking about, and we have notes on this. You need to go back and look at the notes if you can't remember. But since this is increase, this is going to be the one with a plus. So y equals a, our beginning value. And then we had that 1 plus b, which was our growth. So that's going to be 0.05. And then we're just going to say to the x power, because technically the x should be time, but they don't tell us the time. So we're just going to leave it as x because we don't know. Sorry, let me erase this. This should have been, our beginning value was 500. Now, we can't solve this because we don't know what x is. So this would be your answer. If they told you what would the value be after 15 years, you would put it in there, right there where the x goes. You would take x out, put 15 in, put it in your calculator, and you would solve it. Don't worry about this piece. Only put that piece, this piece in your calculator. But if they said put 15 years, you would just put that in there. That's just an example. I don't think we have a question like that. You're just going to have to show how you would write out the equation, just like it did. So let me go over that one more time. We're going to start out with just the generic equation, y equals a 1 plus r to the x. This is r is your rate. A is your beginning value. And again, there are notes on this. So now I have my information. I know that my beginning value of that painting was 500. It gave us a percent. We turned it into a decimal. That's my rate. So I'm going to go plug it in up here. Y equals 500. It increased in value, so it's 1 plus, not 1 minus, 0.05 to the x power. And you're done. All right, guys, I hope this was helpful. I'm going to try to close this out as quickly as I can, but I hope y'all have a great rest of the week. You can always Google, in the Google Classroom, just send me a message if you want a one-on-one session, or if you need to just ask some questions. We're always here for you, okay? So if you need me to clarify anything, just let me know.